Math 1314, section IC1, spring 2022, Tyler Junior College, section 5.1, distance and midpoint, video 1, distance formula. This is actually a really easy concept, and it may be a concept that you've seen before, especially if you remember the Pythagorean theorem. To kind of get you started, let's pose a question. What is the distance between the points 4, 1, and 10, 9? I could draw a picture of this, and I will in a moment, but I want to get an accurate representation. So I'm going to go to a website called desmos.com, DESMOS.com, and use the free online graphing calculator there to illustrate the problem drawn accurately. You'll notice that I have a picture of the point 4, 1 on a coordinate plane and the point 10, 9. Let's get rid of some of these extra grid lines, shall we? Let's see. There we go. There we go. So I've got the point 4, 1 over 4 and up 1 here, and then the other point over 10 up 9 up here. And the question is, how long is this? Now, when I say how long is it, I mean, how long is it using the scale that was defined by the X and the Y axis? So if I were to turn the grid back on and put the minor grid lines here, then we're assuming that each of these represents a distance of 1, and we want to know how many of those units is it if we travel along this line segment here. I'm going to go back to the whiteboard because even though I'm not going to draw it picture perfect accurate, I think it'll be a decent representation. And then we're going to figure out not only how to find this distance, but adapt so that we can repeat the same process to calculate the distance between any 2 points without having to redo all of the exact same moves over and over again. In other words, we're going to try to come up with the formula. All right, let's get these typed here. This is the point 4, 1. So over 4 and up 1. And then this is the point 10, 9 over 10 up 9. And we want to know how long is it or how far is it between these 2 points. In other words, what's the distance? So how can we do this? Well, we could set up a ruler with the correct scale and put it along there, but that seems like an awful lot of trouble. It seems like the distance should depend upon the location of the points, which it does. And the location of the points each depends upon their X and their Y coordinates. So I guess really what we're trying to figure out is how can we take the ordered pair 4, 1 and the ordered pair 10, 9, use those 4 numbers to calculate the distance of the line segment connecting those 2 points. Well, there's a trick to this, or at least a trick to developing the formula. The trick is to draw a right triangle. And by right triangle, I mean a triangle with the right angle. And we're going to form one by pretending that we're going to travel from the bottom point to the top point, not by a straight line segment, but rather by going horizontally and then turning and then going vertically up to that point. In other words, as if we could only travel north, south, east, or west. And when we do that, we draw this right triangle, a triangle with the right angle right there. Now, can we figure out how far we would travel horizontally and how far we would travel vertically? Well, we can if we think about these ordered pairs in terms of their X's and Y's only. For example, the first ordered pair is over 4, so it's above 4 on the X-axis. And the second ordered pair is over 10, so it's it's over 10 above the 10 on the X-axis. Well, how would we figure out how far it is from 4 to 10? And the answer is we would just subtract. We would say 10 minus 4, of course, is 6, which tells us that we have to travel a distance of 6 units horizontally en route from the first point to the second. But what about the vertical displacement? How far up would we go? Well, if you use the same reasoning, at the bottom, we're up 1, and at the top, we're up 9. So how would we figure out how far up we go? Well, we would just do 9 minus 1 is 8. And if we did that, now we have this triangle. This triangle will look something like this. The bottom side is 6 units long. The right leg is 8 units long. And we want to know how far the distance is along the hypotenuse. Does the Pythagorean theorem ring a bell? Most people remember the Pythagorean theorem is a squared plus b squared equals c squared. But what it really is a statement about the relationship between the 3 sides of a right triangle. Specifically, if you take 2 sides that are not the hypotenuse being the longest side. But if you take the other 2 sides, which are called legs, square them and take their sum, then it will equal the square of the hypotenuse. A squared plus B squared equals C squared. You just got to remember that in this context, C is always the length of a hypotenuse. So in this picture, C is actually the letter D. So what would it look like if we did the Pythagorean theorem to this picture? Well, instead of A, we have 6, so we would start with 6 squared, plus, instead of B, we have 8, so we would have 8 squared, equals, and instead of C, we have D, so it'd be D squared. And that changes it from a geometry picture to an algebra problem, or from a geometry problem to an algebra problem, one that's rather easy to solve. This thing we just showed is a quadratic equation, but it's a real easy one to solve. First off, we could figure out 6 squared plus 8 squared. 6 squared is 36, 8 squared is 64. The sum of those is 100. And that's still equal to D squared. But it's a quadratic equation with a single term, which means that we can solve it using square roots. And we would get D equals plus or minus 10. As an algebra problem, you use the plus minus when you square root both sides of an equation. But as a geometry problem, asking the distance from one point to another, distance is never negative. So we don't need the plus minus, we just need the 10. And just like that, we found the distance between those 2 points. Now, if you're wondering, am I going to have to do this every single time I'm asked the distance between 2 points? Am I going to have to set up the picture, draw the right triangle, measure how long each of the legs are, set up the Pythagorean theorem, and then solve for that? The answer is not really. Not really, because based on this process, we can create a formula by replicating what we just did one more time and taking out all the specificity. In other words, take out all the things specific to this problem. The things that were specific were the 4 and the 1 and the 10 and the 9. So if we try to replicate this generically, it would go something like this. What is the distance between the points x1, y1 and x2, y2? You'll notice I replaced the specific values 4, 1 and 10, 9 with generic values x and y. But I wanted to use x for the first coordinates and y for the second coordinates on both points, but I can't just say both x coordinates are x and both y coordinates are y, because I have to distinguish them from each other. Well, the common way to recycle a variable to say I'm going to use it again, but this time it represents a different number, is to subscript it. So we'll just say our generic points are first x, first y, and second x, second y. Now, how are we going to come up with this formula? Well, we're going to replicate what we just did over here. We're going to set up a picture, draw a right triangle, figure out how long 2 sides are, use the Pythagorean theorem to find the third side. And at the end, when we have something that says D equals, that's going to be our distance formula. All right, so let's see if we can represent this as generically as possible. Now, I'll admit that when we write this generically, we can't assume things like these numbers are all positive, because if they weren't, then they wouldn't necessarily be in quadrant 1. But just for the sake of drawing the picture, we're going to put these points in quadrant 1, keeping in mind that they could be in other quadrants as well, or even on the x or y axis. So here's our x1, y1. And we're also kind of assuming that the second x is bigger than the first x and the second y is bigger than the second y. Although that's not necessarily the case. What we're about to do can be adapted for all scenarios, regardless of which x is bigger and which y is bigger. All right, so how do we do this on the previous page? Well, we started by drawing a right triangle and then figuring out how to represent the lengths of these in terms of the coordinates that were given. Back here, to figure out how far we traveled horizontally, we did the second x minus the first x. We did 10 minus 4 to get 6. If we did the same thing here, our first x is here on the x-axis, our second x is here on the x-axis. And so when we subtract those, we get x2 minus x1. Now, if you're wondering what if the second x was smaller than the first x and that subtraction problem comes out negative, then we could just reverse the order, or we could take the absolute value, because either way it's going to give us the same answer. For the length of the other leg of the triangle, we got to figure out how far we traveled vertically from y1 to y2. But then again, that's just a subtraction problem. That's what we did back here with the y's. We did 9 minus 1 is equal to 8. But here it's going to be second y minus first y. Then if we extract, oops, I didn't put the D that we're trying to find. If we extract this triangle from the picture, We have a D here, which is what we're looking for. We have a right triangle, one of whose legs is x2 minus x1, and the other is y2 minus y1. Again, for the sake of simplicity, we're assuming that the answers to both of these subtraction problems are positive. If they were negative, then we would just subtract them the other way around, or we could take their absolute value either way. And then we hit this with the Pythagorean theorem. The first leg squared is x2 minus x1, plus the second leg squared, y2 minus y1, all that squared, is equal to the distance squared. And here it points out why the order of the subtraction really doesn't matter. Because if we did the smaller minus the larger, for example, back here, if for some reason the subtraction problem we set up was 1 minus 9, then it would come out -8. But when you square it, it's going to come out the same. Whether you subtract it one way and get 8 or the other way and get -8, when you square it, the negative will disappear anyway. And then what do we do after we set up the Pythagorean theorem? Well, we simplified the left side here. We simplified 6 squared plus 8 squared to get 100. But over here, without knowing any values, we really can't do anything with it. So we'll have to skip that step. And then our last step was to hit both sides with a square root. And the purpose of that was to get the D by itself. And we have D equals, and I'm reversing the order of the equation, the square root of, plus in the middle, on the left, a squared parentheses, and inside that, x2 minus x1. And on the right side of the plus, but still under the square root, another squared parentheses with the subtraction problem in it. And that subtraction problem is y2 minus y1. And there we have our distance formula. Distance equals the square root of, open parentheses, x2 minus x1, close parentheses squared, plus open parentheses y2 minus y1, open parentheses squared. It's not that difficult a formula to remember, especially if you remember its origins from the quadratic formula, but I would write it in your notes and use those as the notes on your test. All right, we're just going to take a look at one quick example because they're really not that hard. They're all the same. Just stick in the numbers, push it far as you can, and then simplify your answer. Let's take a look at one example. Find the distance between the points -3, 1 and -1, -5. Now, it's not necessary to draw the picture of this, but just to kind of wrap your mind around what it is we're looking for. If we were to find the points -3, 1, which would be in quadrant 2, and -1, -5, which would be in quadrant 3, we're being asked, what does this distance equal? We don't have to draw the picture to find it, but that's what we're being asked. All right, so what is the best way? And I may have just gotten rid of my formula of my question. Well, that's no good. One second. Okay, I think that was the problem. If it wasn't, this is the one we're going to do. Okay, so what is the best strategy for using the distance formula? Well, the first thing you should know when you're doing the distance formula is that you need the formula for distance. And that formula for distance is D equals the square root. I like to look at the structure of this. It's the square root of a sum of the squares of the differences. Let me pause there for a second. What you see here is the structure of the formula. I'm going to read it again. It's the square root of the sum of the squares of the differences. The square root of the sum of the squares of the differences of corresponding coordinates. So in the first subtraction problem, x2 minus x1. In the second subtraction problem, y2 minus y1. And honestly, it doesn't matter which point you say is first or second, as long as you're consistent. All right, so how would I recommend pulling off this formula? Very carefully. If you struggle with formulas, here's a surefire way to set this one up correctly every time. Number one, go through all four numbers, all four coordinates, and label them. First x, the minute you decide who the first x is, everybody else is assigned. If -3 is x1, then its coordinate 1 is the first y. And on the other ordered pair, -1 is the second x, and -5 is the second y. The second thing I would do is I would copy the formula without any variables. The square root of the sum of the squares of the differences of. In other words, write everything except the x's and the y's and their subscripts, And notice that that 100% preserves the structure of the formula. And then one at a time, drop your values in, which we conveniently have labeled. The first value we put in is the second x, that is -1. That's to the left of the first subtraction. The second value we put in after that is the first x. The first x is -3. Be careful, I have minus and negative. We'll navigate that in a minute. In the second parentheses, we put the second y to the left of the subtraction. The second y is -5. And then to the right of the subtraction, we put the first y, which is 1. Make sure you have it set up correctly, because if the setup's not right, then what happens afterwards is always going to be incorrect. All right, there's a lot going on here, and you can take it in little bitty steps. But most of you know that you go inside and do what's in the parentheses first. I'm going to pause, take my picture off, and move everything up. All right, but like I said, you know to go inside and do parentheses first. So inside the first parentheses is -1 minus -3. Well, minus and minus becomes a plus plus. So you can think of it as -1 plus +3. And when you add a positive and a negative, you subtract and the larger sign prevails. -1 and +3 are opposite, so I subtract to get 2. And since the 3 is positive and larger, then the difference is going to be positive also. In the second parentheses, we have -5 minus 1. Well, that's just combining two negatives and getting a bigger negative. So we have -6. Now we have the square root of 2 squared plus -6 squared. Then I would square. There's a temptation to cancel the squares in the square root here. Don't, because the plus sign in between the squares prevents all that from happening. Instead, you should square both numbers. 2 squared is 4. -6 squared is +36. If you write -36, you didn't square the negative, you only squared the 6. That leaves the square root of 40. Now, in the homework, sometimes this will come out to be nice. Like if this were the square root of 49, then we would just say it's equal to 7. Bring my picture back. Put me over here, not in the way. If it said the square root of 49, we just say 7. But if you get a square root that can be simplified, you will be expected to simplify it. If you don't, it will mark it wrong initially, but remind you that the square root could be simplified. Remember how to simplify a square root. At its core, you break it down into the product of 2 square roots, one of which you can answer. In this case, I'm going to break down the square root of 40 into the square root of 4 times the square root of 10. The square root of 4 is 2. The square root of 10 we don't know. If this were a homework question, this would be the final answer. 2 times the square root of 10. If you need a reminder of how to simplify a square root, I do have a video out there on simplifying square roots. In fact, I linked it in one of your modules or an announcement, but if you can't find it, let me know and I'll hook you up with it. All right, so the distance formula is pretty straightforward, very predictable, very methodical. Just grab the 4 coordinates of the 2 points, the x's and the y's, stick them in the formula in the right place, and then whittle it down bit by bit, which is almost always subtract, square, add, square root. Let me say that again. Subtract, add, that's not right. Subtract, square, add, square root. It's all laid out for you right in the formula.